Thanks for the kind introduction. I'm Toshihiro Kamishima. We are greatly delighted to receive the Test of Time Award. The story begins with ECMLPKDD 2010 at Barcelona. Professor Tun Caldas gave his presentation. 3 approaches for making the naive-based classifier discrimination-free, which was received the ECMLPKDD 2020 Test of Time Award. It was highly attractive for me. The key notion is mathematical notion of fairness. It is currently referred as statistical parity, named by Cynthia work. This is a mosaic plot. This indicates the relation of majority group and the relation of minority group. This indicates the positively estimated class and the negatively estimated class. Caldas quantified unfairness by the difference between 2 ratios. In their 2 naive-Bayes methods, a pair of naive-Bayes classifiers are run for each sensitive group. Then, a joint distribution of y and s is iteratively modified so as to satisfy the fairness condition. While hearing his presentation, I got an idea. This can be formulated as a kind of constraint optimization problem. We can solve the problem by minimizing the objective function, which is a classification loss with a mutual information term, as a fairness constraint. This is a simple formulation. This is also flexible because wide variety of classifiers can be used. It seems a very good idea for me. It would be the happiest moment for researchers. However, it was the beginning of the long winding road. The first model was composed of single classifier with 2 thresholds, 1 for each group. This model was not converged, maybe because distributions of 2 groups are too diverged. In the second model, classifiers are built for each group. This model was converged, but it was unfair than an original classifier. This was because the objective function is non-convex, and its local minimas were bad. Though I tried to improve the optimization methods, but they did not work well. The answer was simple. Each classifier was trained without a fairness constraint term, and then the final objective with constraint term is optimized. This model was published in the ECMLPKDD 2012. I could clear the minimum bar. However, the 2 naive Bayes methods still hold the Sauter crown. This model was more accurate and much fairer than my model. We investigated its cause and noticed the fact that class labels are not generated probabilistically, but deterministically generated by applying a decision rule. By taking this fact into account, the performance was drastically improved. We also applied an idea of introducing a fairness constraint term to a recommendation task in 2012. Its efficiency was improved in 2013, and our fairness term is more precisely approximated in 2018. In my opinion, there are three criteria in data science. The effectiveness is how accurate the prediction is. The efficiency is the scalability. The validity concerns how reliable the prediction is. Each community of data science seems to weigh these criteria differently. Currently, effectiveness and efficiency seems to be more focused for me. However, factors for validity, such as fairness, would become more important to put the data science to practical use. Finally, if you're interested in fairness-aware machine learning, please check my service slide available at this URL. That's all I have to say. Thank you for your attention.